Hello everyone, my name is Kila and today we'll dive into nuclear chemistry, focusing on how nuclear bombs work. Nuclear bombs are one of the most destructive technologies ever developed, and they rely on the principles of nuclear fission and nuclear fusion to release massive amounts of energy. First, let's talk about nuclear fission. Fission is the process where the nucleus of a heavy atom with an atomic number greater than 85, like uranium 235 or plutonium 239, splits into smaller nuclei. When this happens, a huge amount of energy is released. This process is what powers atomic bombs, such as when dropped on Hiroshima and Nagasaki during World War II. In a fission reaction, neutrons are fired at the nucleus of fissile material. When the neutron hits the nucleus becomes unstable and splits, releasing energy in the form of heat and radiation along with more neutrons. These newly released neutrons can go on and on to hit other uranium nuclei, causing more fission reactions to occur until creating what we call as a chain reaction. So, how does this chain reaction lead to an explosion? The key to nuclear bombs' explosive power is the chain reaction. As more and more nuclei split, the number of neutrons rapidly multiplies, causing an exponentially increasing number of reactions. For the bomb to explode, it must contain this chain reaction until a critical mass of fissile material is reached. Critical mass refers to the minimum amount of fissile material needed to sustain the chain reaction. Without enough material, the chain reaction won't work. But once critical mass is achieved, the reaction happens quickly and releases immense amount of energy that the bomb explodes with incredible force. So let's talk about the components of a fission bomb. To make a nuclear bomb to work, you need several components like fissile material, like heavy atoms like uranium 235 or plutonium 239, which undergoes fission. Most commonly used material is uranium 235 because they are easily found, and the less common one is plutonium 239 because they are not so easy to find, and neutrons, which initiate and sustain the chain reaction. Explosive, which compresses the fissile material to achieve critical mass instantly. So it also requires nuclear reflectors, which help reflect escaping neutrons back into the fissile material so that it can so ensuring the reaction doesn't stop prematurely, so the chain reaction continues. Explosive compress the fissile material, instantly bringing it to critical mass and rapidly unfolding the chain reaction. Neutron reflectors, often made of materials like beryllium, help bounce neutrons back into the core, ensuring that as many neutrons as possible contribute to the chain reaction. Now let's talk about how hydrogen bombs work. While fission bombs are immensely powerful, hydrogen bombs or thermonuclear bombs take things a step further um, by using nuclear fusion. Fusion combines lighter nuclei such as hydrogen isotopes to form a heavier nucleus, releasing even more energy than fission. The fission reaction from an atomic bomb generates the extreme temperatures required for a fusion in a hydrogen bomb. These temperatures, which are like millions of degrees, are necessary because the positively charged hydrogen nuclei naturally they are so tiny and they are highly repulsive to each other. However, they fuse once they overcome this repulsion due to high temperatures, releasing immense energy. So let's see what are all the components necessary for nuclear fusion. To achieve nuclear fusion, several elements are essential. The most important ones are the isotopes of hydrogen, like tritium or deuterium. Extreme temperatures, usually produced by the fission bomb to initiate the fusion process. Fusion bombs, also called hydrogen bombs, are vastly more powerful than fission bombs. While fission bombs rely solely on splitting atoms, hydrogen bombs use a combination of fission and fusion reactions, making them exponentially more destructive. So, how it comes together? So, how does these components work together in a nuclear bomb? The bomb is carefully designed so that the fissile material is brought to critical mass through the use of explosives. The fission reaction produces neutrons and massive amounts of energy, leading to a chain reaction to occur. In the case of a hydrogen bomb, the energy from the uh, fission sorry fission reaction is used to ignite the fusion of hydrogen isotopes, leading to production of even more powerful explosion. The entire process, fission or fusion, releases energy through Einstein's famous equation, like E is equals to mc square, where a tiny amount of mass is converted into enormous energy. So, in conclusion, nuclear bombs harness the immense power of nuclear fission and fusion reactions to create an explosive force far beyond the capabilities of conventional bombs. Thank you for listening. Have a wonderful day. Bye bye.